Okay, so what we're doing is we are doing confidence intervals. And so, in order to do a confidence interval, and so these confidence intervals are usually done with meaning that you have a two-tailed test, okay? And so we're going to be doing confidence intervals for these first parts. There's two different ways to this confidence interval. This first formula is going to be it's going to be the average plus minus z-score times the standard deviation over the sample. Okay, so this is the formula that we're going to use for this one. But before we get started, let me show you the three z-scores that we're going to be dealing with. Okay, so if you have a 90 percentile with a two-tailed test, this would be 1.645. 95 percentile is 1.960, and 99th percentile is 2.576. So this is what we're going to use for whenever it asks for a specific percentile. Okay. Now this first one, I'm going to show you how to do it with a 95th percentile. So this is the one we're going to use for this one. Technically I could do all three because it doesn't specify, but right now I'm just going to do the 90th percentile to show you what's happening. So it says Kellogg's is producing Lucky Charms for consumers to eat. They took a sample of 80 boxes, are N, so I already know that my N is 80. Off the line to test whether they are at the correct weight. The average weight is 84 ounces, so the average weight is 84 with a standard deviation of 1.5. So then the standard deviation is 1.5. Okay. We have all this information, and now what we can do is make a confidence interval. What this confidence interval is just saying, it's like when we were doing our hypothesis testing. It's just saying if you go outside this range, all right, we have no confidence in it. We have no confidence that a box would actually be within that range. But what we do have confidence is that within 95%, so that means that we have a 95% confidence that is going to be between this number and this number. So let me show you what I mean by that. So we have this mean right here. So we're going to first put the 84 right there. We're going to put plus or minus. And since we're doing a 95th percentile, the z-score is going to be 1.960. The standard deviation is 1.5. And then this should be the square root of 80. Okay? So the first thing I'm going to do with this is I'm going to figure out what this is. So make it easier on myself. So what I'm going to do is I'm going to put in .960 times 1.5 divided by the square root of 80. Okay, that gives me this 0.329. All right. And since I'm just going to round it, so the 0.329. So I'm going to take 84, and then I'm going to add, then subtract this number. So first I'm going to take 84 and add it. 84 plus 0.329. And this is going to be the upper end of our interval, which is going to be 84.329. This is going to be the upper end. Now we're going to figure out the lower end. So 84 minus 0.329. This is the lower end, is 83 83.671. What this means is that since the average box is about 40 ounces, that if we take any box, we have a 95% confidence interval, or 95% confidence that's going to be between this number and this number. Okay, so that means it's going to be between 83.671 ounces to 84.329 ounces. Okay, this is one way this works. The second way, as I'm about to show you, is if they don't give you all this information. So that's the first formula, okay? This formula is going to help you with this first question, okay? So this first question, that first formula is going to help you with. And it's going to help you with this question, okay? So it will help you with 8 and 10. And it should also help you with 11. Sorry. Should also help you with 11. Okay? But now let me show you how you do number 9. Sometimes you don't have the mean. There's no mean because that's not what the question's asking for. So, what we're going to do is we're going to show you this one about Hillary Clinton. Okay? Oh, I'm sorry. You're going to see yourself. It's going to be kind of meta here in a sec. Look how cool that is. Alright. So, you see that it says, when Hillary Clinton was running for president, NBC polled 2,000 voters, randomly selected between the ages of 18 to 60 years old. If 1,025 voters said that they were voting for Hillary, find the margin of error. So what we need to do is first find our P. Okay? And let me show you the formula for this. So this is P plus or minus z-score times the square root of P 1 minus P all over N. Okay? So, this is the sample. We have 2,000 voters, so we know our N is 2,000. Okay? And now the P stands for percentage. And this is the percentage that said they were voting for Hillary. So we got to figure out what percentage of people were voting for Hillary. Well, it says 1,025 people were voting for Hillary out of 2,000 people. Okay? So if we do that, we figure out that if we take 1,025, we divide that by 2,000, we get the number 0.5125. So this is what our percentage is in decimal form, 0.5125. Okay? And so this is what our P is going to be. So we're going to put 0.5125 plus or minus. And let's say we wanted a 99% accuracy. Okay? So the 99% accuracy, remember, was 2.576. It's from the previous page. And then we're going to do the square root of P, which is 0.5125. We're going to multiply it by 1 minus 5.125. We're going to divide that all by 2,000. So once again, the first thing we're going to do is figure everything out after the plus minus. So I'm going to take, in this case, I'm going to take 2.576. I'm going to take that square root of 0.5125. Actually, I'm going to put this in parentheses because this should always be in parentheses. Actually, no, I don't need to put this in parentheses. I'm going to do 1 minus 0.5125. That part I did have to put in parentheses. Divided by 2,000. What that gives me is 0.0287, or 0.0288. So I'm going to use 0.0288. And then we're going to use this number right here, and we're going to put it right here. So it's going to be 5125 plus or minus this thing. Okay, so first I'm going to do the plus version, so that's 0.5125 plus 0.0288, and that gives me 0.5413. So this is going to be the upper end. 0.5413 is our upper end. Our lower end is when we do the same thing but subtracting. So I'm going to do 0.5125 minus 0.0288, and I get 0.4837. So that's 0.4837. So that means that we think Hillary Clinton is going to get between 0.4837 or 48.37% of the vote and 54.13% of the vote. So that what that means is that she could either be, we have a 99% confidence that she's either losing by a small margin or winning by about, I don't know, about 4%. So it's like either losing by a little bit over 1% or winning by about 4%. So that's about the range, and that's what these polls usually do. They usually tell you, well, we think that she's going to get 49% of the vote, plus or minus 2%. And that's what that means, is that they're trying to calculate using a confidence interval based off the fact that they only surveyed a couple of people. All right, so that's how we do number 9. And then in the next video, I'll show you how to do the rest. Actually, I'm sorry. This is still technically part of the same chapter. We're going to do the null hypothesis and everything like that. And I'm going to explain one off the test that we just took. Just to explain everything. Sorry. All right, so let me get my internet to load and everything like that. Okay, so right now what I'm going to do is I'm going to read this off and I'm going to explain it. So it says, a fat camp is claiming that the average person loses 50 pounds while being at their camp. The competitive camp, or the competing camp, claims that they're lying and the average person actually loses less pounds. They asked 16 people and found that the average person only lost 43 pounds with a standard deviation of 10 pounds. If the data is a normal distribution, can you reject the null within a 0.01 significance? Okay. So this technically reaches on what we just did. You guys just didn't see the connection just yet. Technically, we're doing what's known as a 99% confidence interval. We're trying to see within 99%, are we able to, do we have a 99% accuracy with this whole thing? So first off, we need to know what our H naught and our H naught, our null hypothesis, and our alternative hypothesis are. Okay, so first we need to figure out what the null hypothesis is. The null hypothesis is if nothing changes. What would happen if nothing changes? Well, is that the quiz says that if nothing changes, then the claim stays the same. So HO is that they lose 50 pounds. And their competing company is trying to say, no, that's not right. So the HA is just a counterclaim saying, no, this is not right. This is what the correct information is. So this is what they're trying to prove. And they're trying to prove, and the proof is that they lose, on average, less than the 50 pounds. So that's what the competing thing is trying to prove. Okay, is that they lose less than 50 pounds. And so what we're going to do is we're going to figure out now the type 1 and the type 2 errors. Okay, so the type 1 error is if you reject the null when you're not supposed to. And so what that means is that we are rejecting the fact that they lose on average 50 pounds. So what happens if we reject the sorry, guys, I'm going to take a quick 30 seconds and make sure this is right. Okay. So, is rejecting the null. So if we say type 1, that means that we're rejecting this, but we're accepting this. Okay, so if we reject something, that means we accept the other thing. So we say, so the type 1 error is that we believe they lose less than 50 pounds, but they actually lose 50 pounds, okay? So that's the type 1 error, is that we believe that this is false and that this is true, but but in actuality, it's not true, okay? And the second one, the type 2 error, is that we fail to reject the null, which means that we think the null hypothesis is still true, when actually the alternative hypothesis is true. So it's the opposite of this, is like we believe you lose 50, when in reality, you lose less. Okay? Now, both of these errors can actually hurt the company. Like, this error right here, what it does is it hurts the consumer because they think they're going to this and they're about to lose. Actually, sorry. This one hurts the consumer, this one hurts the company. This one hurts the consumer because they believe they're going to lose 50 pounds, but in reality, they're losing less than that. And then this one, they are actually hurting the company because the company is getting a false claim saying that their statement is false, but when in reality, it's actually true. So both errors can actually hurt somebody. It just depends on which person does it hurt. Does it hurt the consumer, or does it hurt the what is it called? The company itself. Okay, so those are how you do type 1 and type 2 errors. Then now the next thing we're going to do is we're actually going to figure out whether or not this is true. Okay, so first off, we're going to look at the z-score for the confidence interval we're looking at. Okay, so the confidence interval, this time we go to their t-chart. The reason why we go to the t-chart is because we did a hypothesis testing, all right? So what they did was that they asked 16 people. So we have to actually go one less than that for degrees of freedom, and we look at 15 people. All right, so we're at 15 people. And we want a 0.01, so this is a one-tailed test because we're trying to figure out less than, all right, just specifically less than. So we go down, we figure out that the z-score is, in fact, what is it? 2.602. So we know that this is what we have to beat, okay? And now, since it's on the left end, like, because remember, what we're actually trying to do is, here's a normal curve. We're trying to prove that they're losing less than, so that means that less than is in this area right here. And since it's in this area right here, we're trying to beat a negative z-score, okay? So at this point, we need a couple different things. We need the population claimed average, which is 50 pounds, okay? We need the x-bar, which is the pounds that the people figured out, which was 43. We need to figure out the standard deviation, which was, it looks like 10 pounds. And then finally, we need to find the n, which was 16. And so remember, the formula is this. It is x bar minus the mean all over the standard deviation divided by the square root of n. So in this case, the x bar is 43. We subtract 50. We put all that over 10 divided by the square root of 16. Okay? So put the top part in parentheses, put the bottom part in parentheses for this reason. If you do not, your calculator will not understand what you're trying to say. So we're going to put this in the calculator. So we're going to put 43 minus 50. Okay? And we're going to divide that by 10 divided by the square root of 16. Oh, sorry. And we get the answer, negative 2.8. So this is the answer, negative 2.8. So what we're going to do is we're going to compare this answer to this answer. All right? If this answer exceeds this answer, meaning that it's further left than this answer on the number line, that means that we can reject the null. And in this case, this number is farther left than this number. That means we're going to reject the null. And remember, the null meaning that the average person actually did lose an average of 50 pounds. So we're going to reject that null, and we're going to assume that our claim was correct, that they do lose on average less than 50 pounds. Okay? And that's how you do this chapter. If you have any questions, please ask.